All right, hello everyone, and welcome to today's webinar. A few of you have already chimed in on our question board, but if I can get a confirmation that you can hear me and see my screen, you should be seeing measuring HVAC performance on your cover there, so that'd be great. Thank you for those who are chiming in. Sound is good, and hopefully you guys can see the screen. Excellent, everybody. Thank you. So I can tell many people are returners, knowing that our webinars are very interactive as much as we can. We really like your feedback and want to make sure you feel informed to get your questions answered. So let's move through here. So I try to eliminate some of these initial slides, but right now, because I know you can hear me, you should be able to hear me, and many people already found the question panel. So if you have questions during this, there is a lot of complicated stuff here. Some of it we can answer, and some of it we'll have to get back with you. So your control panel is controlled by the little red arrow. So let's keep moving. Okay, so that's me on the right. Jay West is usually kind of typing in the answers in the background there. And Colin Gibbs in the middle, who will be also providing some major insight to today's session. If I can get everybody to mute in the background, please. Colin, are you muted?
Muted.
Thank you.
I was.
Okay. Oh, somebody. Okay. I'm also joined today by Jeremy Bagley. He's been a good friend and a co-presenter and trainer for many years, and he's going to give us some insight. He actually lives, eats, and breathes some of this stuff every day, and will kind of give us the hands-on interpretation of some of the things that are out there. He's been working as a auditor, home performance professional for quite a while, and just recently launched his own HVAC to home performance consulting firm. So he's decided, instead of just trying to help the homes, he's also now trying to help those who help the home. So he's going to be a great resource for us, and you'll see him at many of the conferences that are going around the country also. One of the things I'd like to promote is Jeremy did go to a company several years ago, and I can't disclose who it was, but he increased their revenue by adding home performance with HVAC, and they added, you can see the numbers there, 250,000 gross revenue. So those are some really phenomenal numbers. Clearly covered his salary. So, and probably by the first year, they were close to $500,000 in additional revenue. It's one of the reasons why HVAC and home performance really should be a great partnership, or really just one entity, and they both should be helping each other or including each other in their services. We do have some CEUs, so if you did not enter your stuff, give me your name, email, and BPI in the questions box, and we'll make sure you get your stuff. I'm not going to do actual official polls today, but I am going to do polls, and I call these running polls, which means if you could just chime in the background, lets us know you are paying attention, but I don't have to stop and wait 60 seconds for the poll to go by. What kind of gauge do you have? That actually kind of helps me a lot when we talk about some of the stuff we'll do with the gauges today. So if you could chime in as to DG700, DM2, DM32, I appreciate it. I also do not going to do an official poll for the market sector, but what we're looking for is, are you a home performance contractor, HVAC contractor, auditor? That would include HERS rater, BPI, maybe you're a code official, maybe you're a support staff technician. However you describe your role in your company, if you could describe that, that'd be great. I'm only going to do one slide on retrotech.com because it's the place to go for all your resources, and this is where all of our webinars are. If you want to look for more webinars, it is on the support page. And if you're looking for past webinars, they're on the YouTube channel. And we record these. I am recording already, so they get edited, usually within a week, sometimes two. You can find them up on the YouTube channel. If you subscribe, you'll get an email letting you know when the latest and greatest webinar has been updated. One last plug. We really find a lot of people are not actually updating your firmware. Please update your firmware. You can download the configurator from retrotech.com. Many places to look for it on your device, and you should be at 2.4 build 71B1. If not, you should definitely upgrade your gauge. rCloud's beta, you can go to retrotech.com, rCloud beta. We're actually now working with this, and if you want to become more a part of actually doing beta testing, you can sign up there and be included in our webinars and our official announcements. A lot of people ask about the gauge. They're still doing that upgrade, trade in one and upgrade to the smart gauge. So those are always out there. Today, we're actually going to deal with things that would normally take most of a day or part of a day, and think of this as just kind of an introductory overview. That there's no way that we can go into all the in-depth details about how to do some of these. So our goal today is to talk about measuring HVAC home performance. And what we usually do is we do an overview like this, and over the next part of the year, we'll take each one of these topics and break it out into an individual session so that we can actually spend much longer time on that and get all of the details actually incorporated. So today is kind of an overview as to how some of this stuff works. All right, so we are recording. Today I'm going to talk briefly about the gauge. Many of you are familiar with the gauge. As I look out there, I see a kind of a mix, as we normally get, of Energy Conservatory and Retrotech folks. I will briefly talk about ACCA standards, because one of the things that Home Performance abides by is some of the most common standards that ACCA has created. It's also an HVAC guidance for installs and confirmation of the install. And if you're going to do anything, you really should be complying with some standard. Many things we cover are international conservation code standards. This is just a different one that's required more for HVAC contractors and home performance professionals. We will cover external static pressure. Most people call it static pressure. And we have a couple other test procedures that we're going to dig into. The duct test with the blower door, total system flow, commissioning. We may or may not actually go do manual J by the time of our end of our session, but we have it just in case. I want to touch briefly upon the gauge, because we're going to talk about using the gauge for several different ways to measure a variety of stuff today. So the gauges, as many of you know, no matter which one you have, Retrotech, Energy Conservatory, it really is two gauges in one. That you actually have a channel A, channel B. Channel A, for most of the times we use it, is for doing blower door or duct test, and it's always reading your test pressure. Channel B is what's providing your results, or the answer as to what really you're testing with. Today we're going to focus more on the fact that there are a positive and a negative for the channels, and you want to make sure that you're actually hooking them up when we do static. So you can see here on the gauge, and if you look at the gauge, it's a little hard because it's built into the plastic, but you can see that each one has a little positive and negative icon next to it. And I'll touch on this, and all of the gauges have that. Even the Energy Conservatory gauge also has that. One of the things I'm also going to touch briefly on is we're going to talk a lot of things in HVAC world are inches of water column, and Retrotech uses the INWC way of describing that. There's a couple other acronyms which I'll bring up, and basically it's the distance from pressure exerted over 1 inch of height of water. And if you're going to talk with HVAC contractors, they usually don't talk in Pascal. They usually talk in inches of water column, multiple inches or fractions of inches, but their world evolves around that. Most auditors are dealing with pascals in terms of your testing pressure, 50 pascals or 25 pascals for our testing units. So many of the folks may be coming from the world of auditing, and we live in pascals. That's usually kind of how my way of figuring out pressures. So I thought I would give you some equivalent test pressure. So when we test in 25, that's 0.25 inches of water column. 50 is 2 inch, 500 is 2 inches, 1,000 is 4, 1,500. And so we can see where we deal with, they deal with inches of water column in a small numbers. To us, those would be like very large numbers of pascals. So if you want to change the results on your gauge from pascals to inches of water column to do a static pressure probe test or some of the other tests that require inches of water column, I'm going to go briefly on how to do that. You can tap the channel B, and it brings up your results to be displayed. And at the top would be pascals, because that's most of the people already reading pascals. If you just tap the same area again, you're actually going to start switching to the other options that are in there. From inches of water column, you can tap it again, and you'll get pounds per square foot. And it'll just cycle through your different options every time you actually tap it, and you can get your results. So it'll go back again to pascals, and you tap it again to inches of water column. And then you can either tap the home button or the arrow back, and it takes you back to your home screen, and you can see that not only do you have inches of water column, but it actually reads 0. Lots of zeros as how it always displayed, and that's normal. Many things we'll do today only require paying attention to channel A on the top, because that's where we're going to make some of the connections for the tubing. So whatever kind of device you have or whatever kind of display is in the bottom, it really isn't relevant unless you're going to actually connect it to a blower door or duct tester. So we're going to start with static pressure, and we just want to focus that we have channel A set up to inches of water column. Some of the slides that I have, I did a session with Chandler Von Schrader and Casey Murphy out at ACI at National last year, and this was our focus, was on static pressure and why this is so vital. So, they said I can use some of these slides. So they want more and more people to be focusing on static pressure or confirming the installation. It's required for Energy Star, and many other installs really require that you make sure that it's done correctly per manufacturer or per similar guidelines. And this was a pretty amazing stat that they had, that and I will send out this to everyone here as a reply to show you where this link came from. So I'm just going to pick a question that somebody had, and I'll send it out. So there it is. I also found a free copy, which I actually just sent out to everybody, on how to get a copy of the ACCA Standard 5. This is when it also has been approved by ANSI, that these become very common information that people really want to get. So if you look in your response, you can see that I just sent a link to this also. And it actually has some of the things we're going to talk about and some of the things that Jeremy lives by. And Jeremy, can you explain quickly on some of the places that require the ACCA standard? I know that Energy Star is one of the places that refer to that, or how do you use it in your everyday life?
The ACCA Standard 5 is anybody that's participating in the ACCA Quality Install Program, which is similar to some of the other programs like ResNet, or more particularly, it's a little more similar to a BPI accredited contractor, where you agree to be QA'd by ACCA on a certain percentage of your installs. This is the Bible. This is the installation standard to which you must install all of your equipment. And also, like you mentioned, Energy Star has taken some things from it, and because it is an ANSI standard of installation, so a couple of their checklists that are in Energy Star version 3 have borrowed heavily from the ACCA Standard 5 installation standard. So that's how it's pretty much applied. And even if you're not participating, in the QI program with ACCA, if you're a HVAC contractor and you consider yourself to be a quality installer, it would be a good thing to have this standard in hand and to at least understand it and know what's in it, and check yourself on it, because I've ran into many contractors who say, we already do all that stuff, and then I'll pull out the standard and we'll go over it, and then they're surprised, like, wow, we don't do that. I don't know why that's required. But everything that is in there has a specific purpose to making the system operate optimally and the way that it should. So it's a well thought out, well put together standard, and I highly suggest that anybody that is involved in installing HVAC systems pick it up and get familiar with it.
You might be muted. Thank you, Jay, for reminding me that I'm muted. It is an easy read, and I did put some the links in the chat window also, so you can access those. But it's very not a complicated manual to actually understand what it's trying to say, or even explains how to do some of these. So one of the things that they have in here, again, they're talking about that these things should be confirmed. I just Googled ACCA Standard 5 and found a wealth of information when I was doing some prep for this, and one of which is actually the checklist. And the checklist is actually for homeowners to confirm that they got an install correctly. So ACCA Standard 5 is not just for contractors, but it's also for homeowners or builders to make sure that the contractor is doing the work correctly. These are some of the acceptable procedures on how to evaluate that. And today I'm only going to focus on a few of them because they actually don't really partake with the kind of equipment that we're really going to refer to. So we will do a static pressure drop. We will talk about flow grid measurements. That may kind of be towards the end there. And I do have some information on pressure matching method. So these are all kind of things that we're going to go through, plus a few other procedures. In the standard, it does have a whole section about duct leakage. It's very similar to the code applications that are out there. So I really don't want to spend a lot of time on it, but let you know that there is something out there. It does have some guidance about existing ducts and leakage, and it's pretty, it actually deals with the percentage, but it deals with the percentage of the air handler, not the percentage of the floor area like we do in the code. So if you're going to read it, make sure you understand the percentage that it refers to. We're also going to talk about the airflow balance section, which is kind of referred to maybe as commissioning or making sure that all the rooms are getting the type of air that they should have. And there's a few procedures that we'll use that we'll check here. So you can actually do, again, you can do a duct test for this, or we're not going to talk about a hybrid method where you actually can use a blower door and your a flow hood to actually do this measurement. It's a very common way of measuring duct leakage or your total leakage to the outside using this method. We're going to start with external static pressure. I got several slides on here, and again, this could be a solid hour course going in details about all the different options that are out there. So again, my goal is to make sure you understand an overview of what some of these are. And there's multiple phenomenal resources on YouTube about how to do these by several other people in our industry. But I want to make sure you understand how to set up our gauge, how to set up the gauge, and go through some of the procedures. Most people just call it a static pressure test, and the word really is they call it external static pressure when you're dealing with a gas furnace or dealing with the type of air handlers that in that kind of system. The internal would actually be considered a heat pump or something that didn't have those type of applications inside of it. So we call it an external static pressure because the actual area that we're measuring the resistance of is considered external to the rated appliance. It's not all integrated inside of it. The most common number that most people shoot for is 0.5 inches of water column, right? So this is not an absolute, but it is kind of like shoot from the hip and gives you a number. But you really want to make sure, especially in today's type of units that you're dealing with, that they actually have a spec sheet that tells you exactly what it is that this should be. So, and remember that it doesn't take much, like 0.6, 0.7 could actually be a really large amount of flow that's no longer actually getting through your air handler. So we're going to talk about those and show you where those can show up on your sheets. Some things that are actually causing these issues in terms of having higher static pressures or a bunch of resistance that's in there. The evaporator coil is either dirty. When you're testing, you're usually dealing with a wet coil, but there are procedures for dry coils, which means that it has a moisture in it, or it's not brand new without any kind of fluid that would have been applied. If you run air conditioning, when you're also doing this static pressure, you're usually going to do it in a high-speed test, which means that you're going to be doing it on either air conditioning mode or make sure it's set for the higher speed of airflow that you normally use when you do an external static pressure test. The other one that's the most common one is that can be an issue is that not dirty coils, but folks who have either not changing their air filter or decided to put in a MERV 50 type of air filter that's will catch every particulate and probably a lot of air will not go through it because they decided to put something that they thought would be a much better way of better living for their house, only to realize that they really stressed out their system in terms of the amount of airflow that now gets through to it. And it really makes makes your motors work very hard, or makes your energy bill move up depending on the type of motor that you might have.
Joe, can I jump in real quick?
Please.
So I just want to say, based on everything that you've said so far, and that is, if we're talking to homeowners in the home about external static pressure and static pressure and all this stuff, their eyes are going to glaze over and they're going to pass out. So a good friend of mine, David Richardson, who is part of the National Comfort Institute, he has a really easy way of referring to static pressure that I like a lot, and I just want to pass that along to the folks on this webinar. He refers to it as the blood pressure of the system. So, and you know, in talking to homeowners, he'll say, just like we have a certain blood pressure that we need to be at. If it gets too high, that's bad for us. If it gets too low, that's bad for us. And so it's the same way with the HVAC system. There is a certain static pressure that your system optimally operates at. And if we test it and it's too high or too low, it indicates certain things to us that could be wrong, just like your blood pressure would do for a doctor, and gives us hints on what we need to adjust. So I always like to make sure that we have a good way to talk about these things to the homeowner, because at the end of the day, if we understand it and they don't, then we really haven't done our job well.
Yeah, that's a great way. And one of the things that we talked about, for those of you that caught our webinar that we had 2 weeks ago, it was about how to do testing, but how to get the best bang out of your buck, which was to how to make sure that it, you know, has a sex appeal, and that your actual clients are kind of involved when they see what you're doing and they understand how you're measuring stuff. And sometimes the static pressure part is something you may want to do later in your measurements, because they're not going to really, unless your air handler is in the basement, they're not going to go in the attic or see what it is or see what those numbers really mean. So some of the other tests we do are things you may want to do earlier. Our focus today was a lot more on the technical side of that. The wow factor is something that we referred to last week, but being able to explain when you feel there is a high static in the system. Jeremy, that's a great reference in terms of the blood pressure, so well done. This is a common way of determining if I have 0.5 inches of water column of my total static pressure, then you can imagine that I have to figure out what parts of the system may actually have various restrictions. So, you know, we have your return ducts and kinks and every elbow or different type of connections, or you can have your flex ducts that are not well supported and they're sagging or collapsing. All of those can create some major restrictions and increase your blood pressure or your static pressure. The grills and the filter, all these things are what really can be different parts of it. And there are extra ways of using your gauge to isolate where they may be by putting your probes on both sides of like the filter, or between the filter and other parts of the system, to determine which one of these is actually my greatest issue that I'm having. So you need a manometer or a gauge, and you need some kind of pressure tip and a pitot tube to do some of the measurements we're going to talk about. What we're going to focus now on is that you really just need a gauge and a static pressure. And we're going to talk about the difference between a static pressure probe or a pitot tube, just so you understand the difference, because they kind of look alike and they're easily misidentified regularly. So you can use any of the gauges that are out there. You can even use some of the basic gauges like the Testo 510. It's a very, we call it a keychain type of manometer, incredibly small. But again, any of these are things you can do. Sometimes contractors will get the simple manometer just because their guys are throwing it in their toolbox. So do you want to explain how you describe the difference between the static pressure and a pitot tube, and which one you use where, Jeremy?
Sure. So let's start with the static pressure probe. Static pressure probe, as you can see, is a single hose device. It only has one port to go in and out, and it's simply going to measure differential pressure is another way that static pressure is actually referred to. And so what that means is it's going to measure the difference in pressure between one place and another. If you're familiar with the home energy concept, you know that we often use the gauge to measure the pressure difference between the inside and outside. We refer to it as with respect to the outside. In the HVAC world, we're often using static pressure most of the time to measure the difference in pressure between the room that we're in and the pressure inside the ducts. Static pressure is a evenly exerted force that is exerted evenly on all sides of the ductwork itself. So that's all you can use. The only thing you're ever going to get out of a static pressure probe is a static pressure measurement. There are ways to determine airflow using static pressure if you have other information like what the fan is actually putting out at that time and manufacturer's chart, but there is no direct mathematical correlation between static pressure and CFM airflow. On the other hand, there is when a fan is in movement, there's another pressure profile at work. This is known as velocity pressure. So velocity pressure is moving pressure or a dynamic pressure. And we get that pressure by the difference between total pressure minus static pressure will give us velocity pressure. Velocity pressure, stay with me here, folks. Velocity pressure has a direct correlation to velocity in feet per minute. So with velocity pressure, we are able to actually determine velocity, or the amount of air, how fast the air is moving in the ductwork itself. So once we actually have velocity, a velocity pressure measurement, and are able to determine velocity, then we can use that number to actually determine CFM air movement. So there is a direct mathematical correlation to velocity and CFM, which is a very simple math formula. It is the square footage or area times the velocity will give you CFM. So if you have a pitot tube, it will allow you to measure velocity pressure because it has two tubes, and it actually allows the gauge to do the math and give you, if your gauge will do it, velocity, or if not, it'll at least give you velocity pressure, which you can then convert into velocity, which you would need a formula that's not up here, but to make it easy, Residential Energy Dynamics has a little plug-in that you can use to get that number. And once you have velocity, you'll be able to determine CFM. Hope I didn't confuse anybody there.
Joe, I'd just like to make a quick comment on that. Typically, pitot tubes have a static pressure component in them. It's very rare. I've actually never seen one in my 30-some year career of an actual pitot tube without a static probe attached to it. So you'll probably find static probes that are picking up the pressure around the circumference of the tube, like the one on the right, and you'll find pitot tubes like the one in the middle. You'll probably never find a pitot tube like the one on the left. So the way to tell the difference is the pitot tube has got two connections, and the static probe has only one. So I was just reading in the Energy Conservatory manual last night that they actually have a velocity setting on their gauge. I haven't tried it before. If you take a look in our manual, there's a section in there that tells you how to use whole flow in order to convert a pitot tube reading directly to flow. So you can simply follow that section in the manual and it'll walk you through it. That was it. Joe, if you're talking, we can't hear you.
Great, thank you. I do know that it's a feature in the DG700. You can do that automatically. I know that Jeremy's used that, and that I know you shared with me, Colin, that it's your goal to get that into the new feature in the DM32, that you can do that also. The other thing I'll point out is usually if you want to know exactly if it's a pitot or static, is only one of them has an opening at the tip. And Colin's right, most of them do have two ports, but if you really want to make sure there's an opening on the tip, you have a pitot tube. If it's sealed on the end, you have a static pressure. So, all right, let's go. Jeremy explained the difference between velocity and static, and when you're going to use one or the other, and how to calculate these. And I do want to mention that I got this from Jack Rice from ACC Training. Instead of trying to rewrite it and do it, I just thought I would give credit to where the source came from. This is one of the documents that Jeremy wanted me to share so he could explain the math that's behind that. So, So we now know there's a polarity, which you saw in the earlier on the gauge part, that there is a positive and negative, and that gives your readings better accuracies in terms of which way you're going to connect onto your system. All right. So where to test and how to test. Jeremy, you want to kind of talk us through how you use this, how often, and what are some of the kind of air handlers you see, and where. And I also have a couple of pictures about tube placements. So why don't you go ahead?
Okay, so I guess you want me to talk about where to test?
Yeah, where are you trying to place your probes for the most common test? And I got a couple other that have heat strips and others. So yeah.
Okay, so for this slide here, it's actually showing taking what we call total external static pressure. So the easiest way to think about this is we want to measure where the air is coming into the air handler at and where the air is leaving the air handler at. So typically we're going to go right above the coil in the supply plenum. And when I say right above the coil, I mean know where the coil's at and drill above that, because trust me, you don't want to drill into the coil itself. I've made that mistake when I first started out doing this stuff, and your company or yourself is going to end up putting a new coil in because all the freon's going to drain out and the coil is going to be ruined. So please make sure that you know where the coil is in that housing and drill above it.
Wait, let me help you.
Returns.
So are you saying, because my illustration I have in one of the static that I get from the company is they want to know right before the AC coil, if you can see the illustration.
Okay.
Right. So there's two different ways to do that. One is if you include the coil, and the other one is if you get a static and it tells you before or after the coil. So your information will clarify, just so people can look at the illustration and know that this probe is actually just before the air coil, and but you can also do it after, and they have different numbers depending on how the unit is configured.
So let me just talk about that for a minute. So if you're going to measure before the coil, then that's including the coil and and the total pressure that you're getting, and that's actually considered pressure drop across the coil. So typically, when we're just wanting to know what the external static is on the system after the coil, we would go right above the coil because the air flows through it, and then that's what's leaving, and so you're going to get what's leaving the system and what's coming in. So if you want to take a pressure drop, then you would go right before the coil and get that piece of information before and after, and then subtract, and then your difference is going to be your pressure drop across your coil.
Go ahead. So what Jeremy's saying is you can also just measure around the coil if you want to find out what your pressure drop is of the coil. Oops. Go ahead, Jeremy.
Okay. And then for the incoming air, you just want to be about 8 inches above the filter rack. 5 to 8 inches above the filter rack is typically where we would measure on the return side. And then those two numbers added together is going to give you your total external static pressure. So that's it for that slide.
One of the hardest things is, so here's an illustration that maybe you're explaining where you're measuring and some of the other keys as to how to get there. So can you talk about some of your challenges as to how to get to some of these locations? Sometimes it's easier to get to the blower motor because there's lots of openings down there that actually where wires are penetrating or other parts. But sometimes trying to get just above the heat coil or your heat exchanger can be a challenge. And some people actually take off components to get to it. So what is your process that you usually do?
That is the same thing. I'll just look at it and see where I can go in. Sometimes there's some seal tight that you can slip the thing in between, and then you don't have to drill anything, and that's helpful. Or if not, then you would have to end up taking something apart to get to where you're trying to actually get your pressure reading at. Other times you may be able to take off the face of it, drill your hole and put it back on if you can figure out where the hole is going to be at, and that way you can put your probe in after you already drilled it, so you're not actually drilling into a piece of equipment.
Yeah, I've seen that there's some units that actually have things pre-installed, so maybe that'll be the future of you can just tap into to a built-in static. So someday.
They do that on commercial all the time. So there are, big, huge air handlers. A lot of times they don't want you drilling into it, and they will have what we call a pressure port right on the front for your static probe. And it's actually not a bad idea for a residential furnace. I doubt that they'll ever do it, but maybe you ought to invent that, Joe.
Yeah, somebody just said, can you pull the limit switch? That's one of the common ways that people do. That's on the previous slide. I didn't have the limit switch out, but that's what I was trying to indicate here on the upper side. Yeah. Colin, Jay, do you have a comment?
Yeah, I just wanted to stop. I got a couple comments in here, a couple questions I think that you or Jeremy might be able to answer pretty quickly. Is the static pressure effectively resistance opposing the system pressure?
Can you say that again slowly, Jay?
Yes. Is the static pressure effectively resistance opposing the system pressure? Resistance opposing the system pressure. Is that what static pressure is?
Resistance opposing the system pressure. It's, I guess you could say that. I'm not really sure. I'd have to think about that question.
I guess I don't really know how to define the system pressure that may come out as some of the things we're talking about, or how to evaluate different components.
Okay, and then there was a question about the static pressure probes. It says, shouldn't the static pressure probes be pointed into the airflow?
Go ahead, Jeremy.
Yes, they should be from each direction. So you're going to want, and here's the thing about it. Yes, technically they should be, but I've done this many times. Flip it around in there, and you can do it for yourself. The change is typically going to be nominal. It's not going to change your static pressure that much. What it will do, though, is effectively change the negative and positive. So if you don't know what you're measuring, like if you're not sure you're measuring supply or return, you can confuse yourself by doing that. So that is the biggest hiccup that will come from that, but you're going to get the same number either way. But technically, if you were writing a manual and you were telling somebody how to do this, yes, it should be pointed into the flow of the air.
Okay, so I have contradictory answers. That's why we have a great discussion as a webinar. So my understanding is that it just has to be with the flow and never turn sideways, so that you're not actually getting a direct flow into the little ports on the side. But it doesn't matter if it's actually going pointed into the flow or pointed with the flow. Colin, do you have any feedback on that?
Well, when you get up to higher velocities, the direction your probe is pointing in becomes more critical. Like on an aircraft at 500 miles an hour, then it's really critical. The low velocities we're talking about, you can spin the thing around 360 and probably not notice too much difference. But technically, it should be facing into the airstream. The reason why that is, when the probe is facing downstream, you've got the air going past the
point?
I guess the horizontal part of the probe that's
called the neck,
basically causing some turbulence to that one pressure pickup point. So if you can put them upstream, it's a good thing. But I think in like learning this stuff, what's critical is to experiment. It only takes a few seconds to play around with this stuff and learn what the effects are, rather than just follow the rules. Check it out for yourself. But if you wanted to follow the rules, you're going to face it upstream.
All right. Any other feedback about placement or some of your most common readings that you do, Jeremy? And do you do this on every system that you commission or evaluate?
100% for sure. Static is the most basic necessary measurement that you can ever take when you are evaluating a system. If you're an HVAC guy, or really, I know there's a lot of home performance folks out there who are just getting into the HVAC field, so they're not comfortable with drilling into the systems and stuff like that. And I've been that guy before, so I know what that's like. But I can tell you 100% get comfortable with measuring static and understanding what it does, because and what the different readings mean, because it is the most basic measurement or an HVAC system that can tell you so many different things about what the system is doing. If there's a restriction in the system, if there's not enough restriction, the airflow is not getting to where it needs to go, could be based on the static. There's just a whole plethora of information as you get into learning about the HVAC system that is a result of what the static is. It's a very important measurement to be able to take, and yes, it should be done on every single system, every single check, every single time.
So for those of you that probably have a air handler in your house and you're going to, like, as soon as the webinar's over, go grab a gauge and go up and try to do this, there's a lot of, like I said, a lot of great videos that are on YouTube from people that are, you know, almost, I could say, almost invented some of this stuff, but really do it in a way that is going to take what we're trying to talk about today into a whole nother level. So there are ways to play with it, as Colin mentioned, but make sure you are careful about drilling any holes in the upper part of the cabinet, and you'll learn a lot about the kind of pressures that move through. And just because your answers may not be 0.5 inches of water column does not mean that your system may be restricted or may have any other issues. You want to make sure you're evaluating that based upon your manufacturer's requirements. So, but this is the most common, one of the most common tests that's out there. Some people have to eat strips if you have a heat pump and you're in a colder climate. That's a very common thing to have.
Joe,
Yes, yeah.
There was a question about measuring pressure at the middle of the edge of the ducts, and I think it brings out a confusion between measuring static pressure and measuring flow with the pitot tube. When you're measuring static pressure, generally the pressure throughout the duct is going to be more or less the same. You want to take it somewhat closer to the edge because you get away from the effects of turbulence that can make that static pressure appear high or low at a particular spot. But it's going to be more or less equal throughout the entire duct for static pressure. For velocity pressure, which is an indication of flow, there's obviously maximum velocity in the middle of the duct. Usually it's some kind of a parabolic curve, and the edge of the duct, the velocity is almost zero. So when you're using a static probe to measure flow, instead of just having it sitting in a stationary point, you can either put it in a part of the duct that kind of like gives you an average velocity, you have no real way of knowing what that is, or the classic way of doing it is to extend the static probe across the profile of the duct, spending an equal amount of time in what we call equal areas. So I have found actually just by moving the pitot tube over the duct and setting my timer averaging on about 30 seconds or so, and moving it so that it's spending about the same amount of time in every part of the cross-section of the duct and averaging that, then we'll be averaging the flow pressure, I guess, and turning that into a flow reading. So those two are very different functions and act differently. Hope I made it clear.
Yeah, one of the things, procedures that was that's in the ACCA standard is to use your pitot tube and to do a traverse across a section of the duct that's usually a linear part of the duct that doesn't actually have any lots of turns or radius or in part of a flex duct section. So those are in there. I did not include those in part of our testing options that are there. So there are things you can do with your pitot tube that actually can measure flow depending on the type of device you have, or some are actually a traverse a hot wire or similar that actually can read the flow directly from what you're doing. And you should do the traverse means you're using 2 or 3 sections high and low on the duct and across the center. So if you were to pull a duct apart, you could see that you probably did anywhere from maybe 12 to 15 different areas of your measurements to try and get a total flow from that area. Somebody did ask about will your connections, your fittings, or the way the duct is designed affect your external static? And yes, it will. Every one of your elbows, just on the same way you use water or gas pipes, each one of those actually is a restrictor and actually will reduce your pressure by a certain amount. So all that will add up. So here's a test that's done, and you can look up based upon your manufacturer and the model unit to get the blower table for this system exactly. So you can, do you have a comment? Nope. So, and you can look it up. So their goal was to be around this half an inch of water column, and I would have, for a 3-ton system, and over on the side, it tells me the different tonnage. It tells me what my reading should be and what I'm getting. So if this is where I should be shooting for, then I can see what my CFM would be. So if I measured 0.9, People think that the higher pressure means that you end up with more flow, but it actually gets restricted when the more pressure. So it's like, the pressure builds up because things are not moving through it. So this one actually has a reduction of its CFM because it does have a much higher external static pressure. I did also get lots of comments that make sure you read these clearly, because some of them do and do not include whether or not you have your AC coil included in these numbers. And some of these are very challenging sheets to do, but if you just stop and read the things that are on the edges, and they always usually have an explanation at the bottom, you can understand what they're trying to provide you and get your results. So it actually can mean that rooms are not getting enough air. The system is being stressed out. It depends on what type of motor you have. So it could even be stressing out the system itself, or we'll talk about different motors here in a second, that it actually could be very expensive if you have a high static pressure, or you have resistance, because some of these newer motors can actually balance themselves to provide a normal static pressure, but it may mean that the motor has to work much harder to do that. Here's one that actually does the coil. Can you explain what you'd usually do when you're doing some of these kind of tests, Jeremy? So you could test. I could test my filter. Yeah, go ahead. Sure.
Yeah, I was just going to say the simplest way to look at it is you're always measuring before and after and just taking the difference, and you're going to find out that's called pressure drop. It's going to tell you what the pressure loss or drop is across that particular unit. So it helps you when you're doing a diagnostic of a system to find out, like, if the AC coil might be dirty. If it gets really dirty, it could be causing undue restriction. Or if the filter's dirty, or like you've made the good point before, if you think you're helping somebody out and you're adding a nice MERV filter in there, gotta be sure that thing is going to be conducive with the static requirements for the system, because once you get up past the MERV 5, or even maybe a little under that, then you start causing a ton of restriction. And just think about, you already have the restriction from the filter itself. For God forbid that filter get dirty, then all of a sudden what's happening? You're choking that system way off. So, I mean, it's going to cause a couple of things. One, it could restrict airflow, or like you said before, if you have a ECM motor, variable speed motor, then that motor is going to start compensating for restriction, and it's like a gas pedal. It's just going to step on it and step on it and step on it, and it's going to be costing people a lot of money. They may continue to get the airflow, but they're going to pay dearly for that airflow. So it is important to be able to take these measurements and know what these different pressure drops are causing.
So someone asked,
go
ahead, Jay.
Oh, I just want to also point out that the other thing that it does is it can cause undue stress on components of the system. So it can actually cause the lifespan of some of the components of the system to end much quicker. So that's another sort of aspect that people need to consider.
Someone asked, what's the best way to determine if the filter is very restrictive, if it's like in or directly adjacent to the return, which is very common, that they'll have a little slot that you move it in and out. I'm assuming you'll just do a pressure on either side of the blower, with or without it, to determine what the difference was, correct? Here's one that I had found as a pretty extreme. If you measure the interpreting the static pressure, so I found the actual document, and could tell me what my CFM was based upon using the medium high speed, my external static pressure, and what my CFM is, and then only to find out that if I had something that was much higher, that you could easily get to a 50% reduction. So the 3-ton is now 1.5. So my readings were not 0.25, which was actually a requirement for the system, and I had 0.9. And you can see the numbers pretty extreme. And if people, you don't really know it, or you're not really aware of it as a homeowner, that these things are actually happening. Kind of like most people who have high blood pressure really aren't aware of it until they go to the doctor, or somebody pulls out a machine and says, "Wow, you really have a significant issue." All right, so I have a slide up that describes the two different types of motors that are out there. You want to see if you can explain that, Jeremy, because you see these a lot. And I will give you the quick one, and that is that the PSC, which is the split capacitor, is the older style, and lots of new homes have the EMC, which is like a electronic, or they also call it a variable speed motor. So do you want to see you explain kind of what the difference is, or how these actually affect your static pressure, Jeremy?
Sure, sure. So PSC, like you said, is I call it the old school motor. It's only going to ever run at one speed. You know, whatever it's set for, that is the speed that it runs at, and it should put out that amount of air. Now, if you have a filter get dirty or some kind of restriction, your coil dirty, then you're going to start noticing a comfort difference in the home, possibly. For sure, the air is going to be restricted, and like Jay said before, it's going to start causing components to go bad much quicker. And but more likely than not, if it gets too bad, the homeowner is going to know about it and they're going to call somebody. Now, with the electronically commuted motor, the ECM motor, that thing is a variable speed motor, and it basically will compensate for restriction. That's what it's designed to do. So if you have a bad restriction and static gets high and you're not aware of it, that thing's just going to keep on putting out air and putting out air and putting out air, trying to make up for the airflow that it is set at or designed to put out. So some people in their home could be getting the exact same comfort but paying 2 or 3 times as much as they should have been because they had a super dirty filter or some other type of restriction. Quick note here, since we all are home performance contractors and we're sealing ducts and things like that, another thing that can happen with one of these ECM motors, and why it's super important to take static after, or actually even before you seal the duct, to make sure that the ductwork can actually handle being sealed up, and then after you seal the ductwork to make sure that your static's not too high. Is with one of these motors, you can get the ductwork too tight. Believe it or not, there is such a thing as ductwork that is too tight. And especially if it's small size, if it's right sized or undersized for the system, you could get it too tight, and then all of a sudden the airflow is going to be restricted. And with one of these motors here, the homeowner would never know about it, and all of a sudden you seal their ducts to save them money, but instead you're costing them money in another manner. So they might not ever realize the savings that you were trying to create for them.
So if I can extrapolate on what you're trying to say, is that situation of saying you shouldn't have it too tight is mostly also dealing with existing construction, that your option has to be your system is poorly designed, and in order to make it run correctly and have ducts that don't leak, it's a major upgrade in terms of sizing of ductwork, sizing of returns, and dealing with lots of stuff that can be maybe not cost affordable, or maybe cost prohibitive based upon what your client has. So there's a certain point where you have to decide that I can't seal your ducts up anymore. And I've talked to many weatherization crews out there, and they're like, we don't do ducts anymore. We sealed them up too tight, and their coils were freezing in the summer because of the static pressure that had been adjusted, and they weren't able to move enough air across their coils to keep it at the temperature it had to be, and things were freezing. So, we all think about how great it is to seal up ductwork, but if you're not cautious or careful about the conditions, especially on existing homes, you can actually cause issues that none of us were aware of at the time.
Yeah, just back to the blood pressure analogy. You get out there and start messing with somebody's veins, you better know what you're doing. That's what we tell the guys all the time. You got to understand what's going on in that system before you just start willy-nilly sealing stuff. But yeah, thanks for extrapolating that, Joe. I was talking retrofit situation there. Sorry I didn't make that distinction. We do assume that in a new construction situation, you're basing your designs off of your heat load and your manual D. So that's a little bit different situation than what I was just speaking of.
So I did get several folks who kept saying, you should go take a manual J class, but don't stop there, because you should understand the manual D, which is the design of the system, and manual S, which is actually how to make sure that all of the components are adjoining, or they're also done correctly. So there's a lot of folks out there that offer those kind of classes. So if you really want to get into static, you should also then be really reaching out to learn more about the design of the system and what does it's sized properly, its actually components are together, and your manual J determines really what kind of how large or what type of system you really need.
So I'd just like to challenge, I guess, the idea of not making the duct system too tight. So essentially what you're saying is that the duct leakage, which is probably happening too outdoors, is giving you more flow across your coils and stopping them from freezing and stuff. So if you plug up those leaks, then you're going, oh my God, I don't have enough air. So we're essentially dumping our energy into the attic because we don't have enough airflow. There are numerous ways to improve the airflow and decrease the static pressure in the system. Allison Bales wrote an article just recently on flex duct systems where they basically were able to cut out half of the flex duct in the attic because they'd put the flex up there, they'd stick a whole box of flex on there without kind of optimizing its length. Whenever you add more flex, you add extra resistance to that system. So there are ways to decrease the resistance of the system. In a lot of cases, a lot of the registers in the house might be closed. There are ways of improving that. There can be ducts that are crushed that aren't getting sufficient airflow and so on. You may even have to put in some extra supplies, maybe an extra return or whatever, to increase the airflow. But the idea of not making ducts tight and allowing that air to blow into the attic because you want airflow over the coil just seems to be counterproductive to me.
I don't think it was.
Yeah, and to clarify, I wasn't suggesting not sealing the ducts up overall as an overall strategy. I was just merely pointing out that if you are sealing ducts, you should understand the whole system. Just like the house is a system, the HVAC system with the ductwork and everything else is a system as well. So you really have to have a grasp on what's going on in that system, and if it does need, as you say, modifications to be able to be sealed correctly, then that should be discussed with whoever the responsible party is, whether it's the homeowner or the building owner or whatever. But yeah, I wasn't saying don't seal the ducts up, just don't seal them up willy-nilly. That's all.
Yeah, so the point you're making is, do the right thing, but look at the big picture. Yeah,
exactly.
I agree.
Exactly.
Yeah, lots of good points out there as to various different things that could be causing, I mentioned the freezing or some other issues. And I think as I mentioned earlier, that the greatest pairing is a home performance contractor with an HVAC contractor. That's just really one of the best things you can have, because there aren't many folks out there that actually can do all of that and do it all well, because you want to be able to do what you do really well. So and I can tell many of the comments that I'm getting from folks that you are an HVAC contractor, and some of the other folks that this is really your focus was HP. And I mentioned that in the beginning. Can you kind of elaborate on why that was such a successful connection, Jeremy? Because you really were able to take another company and put them on another level.
Yeah, it's just because they're, home performance is a natural fit for the HVAC world, because the HVAC world is already getting all the calls for all the stuff that home performance contractors want to fix all the time, because they're the trusted professionals in the community. So for a HVAC company to add a whole home approach just is a super natural fit. All of a sudden, they're going from making basic HVAC recommendations of replacing stuff or maybe sealing a duct here or there or making some duct modifications to actually looking at the whole house for the homeowners that they deal with, and being able to make modifications based on a big picture or a whole home perspective and actually solve the problems for the homeowners. And it really sets them apart from the competition, because those homeowners that actually got their problem solved after having multiple different HVAC contractors come in there and try to fix it over and over again, because that's who they keep calling, believe it or not. They're not going in the phone book and looking for a home performance contractor. 90% of our community doesn't even know what that word is. So they're looking for the people that they've always looked for, which is the HVAC professionals, to come in and fix their comfort and energy problems. And when those HVAC professionals understand and value the whole house concept, it creates external revenue that they never had before, because all of a sudden they're fixing all kinds of stuff that they never even thought about fixing before. So it is a very integrated sales process that's able to take place, and they're able to use the business that they already have, which is the people's homes they're in twice a year on their maintenance contracts, to actually expand even more their business even more, because all of a sudden those folks are telling their neighbors, and their neighbors are coming and asking to get a maintenance contract with that HVAC company that fixed that neighbor's problem. So it's a pretty natural fit.
Yeah, you've done well at it. So I did have one other slide that I'll finish with this, and that is, it just kind of shows your static pressure versus the watts that can actually go into a system. So one of them, the PCS motor, in some of those motors you mentioned can be a single speed. Usually they're common like 2-speed, the winter and summer kind of speeds, but it's the ECM motors where they can just kind of ramp themselves up to make sure they're accommodating a certain static pressure, and in the process can be very expensive for the homeowners.
So
Yes.
one last question before we move on from static pressure. I promised Mo I'd ask, what is the best static pressure rate and why?
Well, I mentioned earlier that
the best static pressure rate is, I'm sorry. Go ahead, Joe.
You got it, Jeremy.
The best static pressure rate is whatever the manufacturer's spec for that piece of equipment is. When you take into consideration all of the different components that we just talked about, which is ductwork, filter, coil, all that added up, there's gonna be a manufacturer spec on that piece of equipment that you should go by, and that is what the static pressure that you want to base all your other diagnostic off of.
Now, where you measure the static, it looks like you're only measuring the static on either side of the air handler or the air handler and coil, but you're really not. You're measuring the entire system together. So if your manufacturer says that it should be 0.6 inches of water column, it's saying that your filter, all of your components, your design, everything that's part of that system should be 0.6. It's trying to take into account, some people describe the external part as the fact that it's taking in all the external components outside of the air handler that give you this reading. So you don't assume that it's 0.6 in an isolated area, but includes all of the features that may be in the design. All right, I got a couple others that kind of go quickly, so we appreciate your patience. In the future, we're going to just probably make many of our webinars 90 minutes. You can bow out early if you want, but we try to provide various information. And when I put together all the stuff on the static, I realized that, wow, this was a lot to ingest. So some of the other ones are actually very much more common, and this is one of the procedures that's called the blower door and flow hood. You can use a powered flow hood or passive flow hood. And this is a measurement that you can use in ACCA. And even in some code compliances, Kentucky allows this type of measurement. So what we're trying to do is put a pressure in the house. And this is a leakage to outside concept. And a lot of HV or home performance contractors use this. It's part of their program that when they teach folks. So basically, when you have the air, the blower door on, it's depressurizing the house. Air is actually coming through sometimes your ductwork, and that's considered because you have leakage through the outside, through the ducts that I can now measure. If you're going to depressurize, it's best that you actually have a powered flow hood. Powered flow hood actually has a motor and a fan inside of it that allows it to neutralize pressures so that whatever flow comes through here, it can actually create a zero pressure by making another fan do the same equal pressure, and you get zero pressure between them. And when both fans are moving at the same speed or actually the same flow, I can tell you what your results are. So this is the powered flow hood that Retrotech sells, and there aren't many powered flow hoods out there. So many things people use are passive flow hood. And this is a technique that most people use when they have a passive flow hood, is they actually will just pressurize the house. So if I pressurize the house, then again, I have the same type of leakage that must move through the duct system to the outside. And I can now move through the house and measure what my leakage is. You can do this at 25 or at 50, but most people do 25 because the code requires that. But there are ways to evaluate that. So when you do this, do you do 50 or 25, Jeremy?
We do 25.
25. Okay.
When we're doing this particular test, yeah.
So you can basically move through the entire system and start adding up the leakage. This method doesn't work as a total leakage, but it does focus on your leakage outside. So under each register, I can then add up what my leakage is, and it also works on the returns so that I can actually evaluate a system. So this is considered a very accurate and a very a strong method to do so. And sometimes it could be less cumbersome when you go into a house to try to get to all these registers and seal them, when actually I can just use a flow hood to cover the register and do my measurements much faster and quicker. So it is something that Home Performance live by in terms of a duct leakage test for themselves. Any comments on this method, Jeremy?
My only comment is the same one that I made on last week's webinar, and that's that I like this particular method a lot if you're doing retrofit home performance evaluations, because it allows you to get the homeowner involved in the test. And that's something that's really necessary in the sales process, to be able to make a connection to the homeowner, or what we call an emotional connection in the sales process. Once they get that hood in their hand and they're actually reading off the amount of duct leakage that is coming out of each one of the registers as you go through the house, their eyes start to light up and they really start to understand what is going on with their system and why they need to rectify it.
One of the other things you can do is, if you can also do the same system, you're not going to do a qualitative, but not a quantitative, but you can use smoke and to do a qualitative. You can actually determine which ones are leaking by just holding up a little smoke generator below the ducts. And if you have air that's moving up, you have leakage there. So it's another way of getting the homeowner involved, and they see the smoke go up. You're like, wow, and then you can even quantify what it is with a flow hood.
I'd just like
yes.
to comment on that briefly. I think the smoke is a good preliminary tool to use. There's no way you want to get them all excited about measuring duct leakage outside and then show that they don't have any. So what we would do is we'd pressurize the house, we'd put a bunch of smoke in front of a few registers. We have no airflow. We're going to be looking for other problems to show them. I mean, the worst thing you can do is get them all excited about finding duct leakage outdoors and not have any. So the essence, I think, of home performance and doing the job right is selling the job in the first place. So the typical method that we have of doing audits, where we take tons of data, is not something that we would recommend in the presentation process, where the person has a comfort problem. You're going to come by and give them some kind of a quote, etc. What you want to do, as Jeremy was saying, is show them something visual so that they can understand what the problem is. Setting up a blower door, using a bit of smoke, using a powered flow hood is the quickest way to do that, and they can actually visualize it. You can also, when you close the bedroom doors, you can get the house to go in an imbalanced state with the air handler running and show them how air is getting sucked in around their doors, down their chimney, and you can even get, in a lot of cases, you can get their hot water heater to backdraft. When they see that, they see right away that they have a very unhealthy home situation, and you want to know about that as well, and all those problems need to be fixed right away. You're giving them an appreciation for a problem that no one else is showing them, and they pretty much often say, well, gee, can you fix that? Anyway, I'm done.
No, you can stay here. So Colin asked me to bring up an image of a fan model that a lot of people in home performance use, and it's just been modified to work with some of the new fans. You want to explain your, brag about your, modular panel, Colin?
Well, a lot of our experience for home performance goes back to about 25 years or so. We're working with the Comfort Institute, which evolved out of Retrotech and then got absorbed into AirSeal a year or two ago. One of the key tools that we had was our hard panel door, which sold at, I think, more than 2 times the price of a cloth door. And the simple reason why we used it was that it's set up really fast, and you don't really want to be spending a lot of time in people's houses mucking around with equipment if you're trying to do a presentation. There's a difference between doing a sales presentation and getting and getting the sale and getting enough money to fix it properly, and then going in and do the job. Once you go in and do the job, you can use anything you like, doesn't matter. So one thing that we found is when people went to the cloth panel door, and there was no interest whatsoever in the homeowner watching that, but when the hard panel system set up, it set up so fast and so slick, it was like, wow, look at this, honey. And I'd have the whole family get dragged to the doorway by mom, dad, and all the kids just standing there watching you putting this thing out because it's really, really cool. So the important thing with doing a presentation in home performance is you have to look good, your equipment has to look good, the processes you use have to look good and professional. You don't want to be coming in there with a bunch of equipment that looks like, we used to call them camcut doors, the old aluminum frame, so on. They just don't have the kabang. That's just the short and tall of it. And I don't know, Jeremy, what do you think about that?
I think that you're exactly on the right track, that any kind of, as you said, bang or pizzazz that you can show when you're setting up equipment, the show is important. People don't want to, especially some people that are, the what I like to call home performance purists. They don't really want to give enough validity to the show part of what we do, but we do have a lot to show people. And if we can do it in a manner that catches their eye and gets them interested in it, then we'd be remiss not to do that. And I think that's exactly what this door does. It plays into that well.
Great. Excellent. Thanks, guys. Okay, I got a couple other illustrations and we'll wrap it up here. I do have a mix of, these are non-animated, they're just stills that I put together. So some are ACCA standards, some are California Title 24 slides and similar measurement practices. The California Title 24 measurements, these are total flow. There's an entire webinar on the YouTube channel for Retrotech that goes through these. But these are similar paths that we've been talking about how they get how we're using certain devices. So this is one where you're going to measure total flow using a blower door. And what you do is you actually are doing a similar to a static pressure, but you're actually doing static pressure from inside the air handler to inside the common space. And once you have that static pressure in the supply plenum, they call it the PSP. Once you have this number, then I can actually hook up my blower door into the return grill and recreate that same pressure that I measured a second ago and get a reading on total flow. So this is one method that you can use in general, but it's also an approved California method that they require that you must validate total system flow for their compliance. If it's in an area that's considered unconditioned, you must open up a hatch and different ways in way you might want to connect that then. So one of the ways you can also just do is this supply side. So again, these are some illustrations just kind of show you other ways you can test total flow that are approved procedures that are out there. We talked about a powered flow hood, and your blower door as well as your duct tester are phenomenal powered flow methods that can be used as a powered flow hood, or they call it a power flow capture hood. So I can actually have the air handler running and it's turned on, and the pressure that happens in the middle here from my duct system, once I actually have reached zero pressure here, then I know that my blower door fan is moving the same amount of air as the air handler. If this was a positive number, then I would be doing too much if it was negative. So once I reach zero, all right, and again, I'm using a static pressure probe here. Once I reach zero, I know that I'm moving the same flow as the air handler. Thus, I can now measure and confirm the total flow that's happening. Sometimes you actually can't hook this up directly to the register itself. There's some restrictions that happen. So there's a couple of devices out there that are, one is called the flow box. It's the only one I've seen. Some people get a big cardboard box, but you're trying to get a neutralization of the pressure here and tap the pressure so it's not directly in the flow, creating turbulence. So this is available from Sierra Building Science out in California. He's a proponent of different methods that do not have to go up and don't cause you to go up to the attic and spend a bunch of time trying to measure total flow. The difference is whether or not you have a single return duct, or if you have multiple return ducts, you have to measure each one. Again, you imagine that you're using your blower door or even maybe a duct tester, depends on the size of the unit, as a powered flow hood. And your goal, again, is you're just creating a zero pressure in the flex duct, knowing that both both the blower door and the air handler are moving air at the same speed. This is one that Jeremy also wanted to talk about, which was commissioning a system. So you do a manual J, and I need to make sure that each room has the required CFM. So Jeremy, do you want to describe your process and what you use to do this?
Sure. And I just want to be clear, there's a whole checklist that goes along with commissioning a system. What we're talking about here is actually commissioning an airflow on a system, so or verifying the airflow of an installed system, which, by the way, if you are an HVAC installer, you should be basing your system charge off of your airflow. So you should be verifying airflow before you actually charge the system, just as an aside, as part of the commissioning. But so this is a real simple process if you own a flow hood or a powered flow hood. You basically are going to look at your designs for each one of the rooms that is going to come from your manual J air heat load calculation. That's also going to give you your airflow per room airflow that's needed, which is what your manual D duct design is partially going to be based on. One of the things that it is based on is the required airflow for each room. So you're going to have that piece of documentation already, and then you're going to go room for room. Hopefully, when you install the system, you put balance dampers in each one of the runs, supply runs, so that you can properly use the airflow for each room and make sure that the fan is pushing enough air to get the balanced amount of airflow to each one of the rooms.
One of the methods that's able to be used in California is you can take a passive flow hood, because there's only ones usually that go up that high, and measure the returns in terms of their total flow. It's one of the most common methods. It's I think their hood is almost 4 feet square, and they use a barometer style passive flow hood. And California does not accept this method of measuring all of the supplies to confirm I have a total flow, but they do allow you to measure it on the return side. So
okay,
yeah.
so I want to clarify something real quick, Joe, here. So you're talking about measuring total flow, and what I was actually talking about was balancing room for room airflow, which the only way you're going to do that is going room for room and balancing the airflow. If you want to measure total flow, that return method is a good method. The best method that I, just coming from an air balance world on a commercial side, the best method, in my opinion, is using a pitot tube and doing a traverse and measuring your flow that's leaving and coming into the system itself. So to me, that's the most accurate measurement. That may or may not be conducive to your program or to what tools you have available, but by and large, I think that's the most accurate way to measure total flow is with a traverse, a duct traverse.
Anyways, because whenever I do the traverse, I always wonder if my hand is going sideways or if I'm keeping it in the right alignment. So interesting. So that's good. That's good feedback. And thanks for clarifying, because you're right. I made this design with California Title 24, but I realized it also could work in terms of a commissioning concept that you're going to got to go to room and trying to make sure that you get the design flow in each room that it's supposed to be. Thanks.
Yeah.
The last one is just to let you know that you can use your duct tester as a power flow hood. So if you're trying to read something like this, you can actually use your duct tester. You can also use it for other things like exhaust fans or kitchen exhaust fans. And the real design is that I'm just trying to match the pressures that are coming from one end out the other. So once I know that I have zero pressure inside the flex, then I do that. And right now, we are trying to do some prototypes to come up with a flow hood that actually could allow you to use your duct tester very easily to do this. The new duct tester is very lightweight. We're debating about holding it up or leave it on the ground. So it's our goal to try and see if we can't come up with a style that actually allows you to use this for some of the things that most people use for powered flow hoods. If you got any feedback, we would appreciate that. All right, and I'm going to jump ahead. Any other questions or something we should cover real quick, Jay?
Well, we did have a question about the difference between measuring airflow at the supply side and at the return side. We've got a Mo out there is testing using a passive flow hood, and he's finding that he's getting 10 to 15% higher or difference, I'm sorry, between the at the supply side. So the supply side tends to read 10 to 15% higher than return side when they use a passive hood. I was going to type out a long answer to that, but I thought anybody, especially Colin, could weigh in.
Colin, you want to extrapolate on the LBL study?
Well, I don't want to talk about the LBL study. I want to talk about fluids in general. When you're using a passive hood on a supply, what you're dealing with a jet of air that's blasting at a flow grid, and they quite often read high in measuring supply flows because of those jets that tend to create turbulence and actually go by the grid more than once, so they get counted more than once, which is why they tend to read high. The LBL study showed that in some cases they read as much as 40% high, and every different supply register will cause them to read high in a different fashion. And that's added to the fact that there's a good likelihood that there's supply leaks, and if anything, they should be really low. So that's kind of an indication you're probably getting about a 25% error anyway with your static flow hood, which is about where they're at most of the time. The powered flow hood eliminates that by pulling the air past a barrier, and it's designed to work very well and still maintain its 3% accuracy even on supply flows. So that's one of the advantages of a powered flow hood. There are many, but that's just one of them.
Jeremy, you got any feedback on that?
No, I mean I've experienced. Well, actually, I do. I have a couple things on that. One, I think it's going to depend a little bit on the type of hood, passive hood that they're using. If they're using a junior Alinor versus a bigger, more commercial passive flow hood that actually has a back pressure compensation on it, then the air factor is going to be a little bit greater, and you're going to experience that. Another thing that plays into that, believe it or not, is on the return side, sometimes all the air is not making it back into the return. So you're supplying a certain amount of air that you're measuring, and then you're measuring what's coming back into the system, and it may not be the same amount.
On the back pressure compensation thing, like they realize they're going to read high, so they put in some kind of fudge factor. So if you're talking to ASIN in Holland that designed the flow line, they put it on a whole series of different registers and get very, very different readings. So they have fairly complicated algorithms that figure this stuff out. So the correction that you can make in a passive flow hood has to be one that's relatively crude. One way to improve the flow hood is to put a flow straightener inside the hood, which is something that some of the newer hoods have, is a flow straightener in there. And Jeremy is right that you're going to get different readings in different passive flow hoods, but they are a bit of a compromise when it comes to measuring supply flows. They seem to give pretty good results on return flows where the air is going through in a predictable fashion. The other form of compensation is that the power flow hood also gets rid of, in addition to the difference in their flow measuring ability, is that whenever you put a passive device on there, you actually change the pressure in the duct that you're trying to measure. So, like, let's say you've got two supply ducts side by side. If you put any kind of resistance on one of them at all, then the air is going to just go out the other register. So, that tends to kind of make them read low. So some things are causing them to read low, some things are causing them to read high. So they're not the ideal tool for measuring supply flows, which is the reason why California wanted to try and institute powered flow hoods. but got a lot of pushback on that since there's so many passive hoods out there. But I would say if I had one tool to diagnose problems in houses, it would certainly be smoke and a powered flow hood. You can do some remarkable things with powered flow hoods in terms of diagnosing not only flow differences, but determining why you're getting pressure imbalances and why, say in some houses that I've analyzed, why the bulk of their return is not coming from the house at all. It's coming from the crawl space, or it's coming from some place it's not supposed to come to, and the power flow will show you that. That's it.
All right. So we are, as usual, we do go over. We apologize. We try. I really, when I like create these webinars, I'm like, oh yeah, this will be about an hour. And then, as I'm finishing up all of the PowerPoint slides, I'm like, wow, I keep trying to feel that there's lots of great information and how to share that, and it's hard to then filter out what you promised that you can't fit into an hour. But many of you do stick around, and I just want to let you know that I really appreciate that. You have your patience is definitely well received on my end. So it's our goal to make sure that we keep experimenting with stuff that we usually haven't covered before. I think we will revisit this probably again in a couple of months, and just focus on the static pressure side, and go a little more in depth as to some of those questions and answers that we kind of tapped into, but definitely could spend an entire probably 2 hours, but we'll definitely hold it closer to the time that we allotted. Jeremy, you want to give us your final take on, some of this testing can seem pretty commonplace for somebody like yourself who's done it a long time. What advice you have to somebody who still is kind of, figuring some of it out?
Learn static pressure. Start with static pressure. That's my advice. Figure out, get comfortable taking that measurement, and then get comfortable interpreting that measurement, then get comfortable talking about the interpretation of that measurement. Measuring airflow, as we talked about, can be done a ton of different ways, but everything really revolves around the static pressure in the system. So that would be the starting point. That would be my advice. Start with static pressure.
Colin, any last advice for those folks?
On there. Sorry about that. I would say experiment. Whenever someone asks me a question, I just go and experiment. I may just use a bunch of cardboard boxes and put holes in them and try things out, and that's really the way that we learn. And so I suggest experiment on your house. Like, for example, measure the airflow in your system with as many different methods as you have. Use the pressure drop method across your blower, and compare that to measuring all your supply flows. And you can do that quite simply by simply putting a box over it. Put your duct tester on top of that box, set the pressure to 0, and you're going to get that reading within about probably 5% anyway. It's going to be pretty accurate, and so you can actually turn your duct tester into a powered flow hood. It's just kind of inconvenient to do that, and you can make accurate measurements around your house and then get a sense of how your system works. And I think that you'll be able to come up with some remarkable conclusions about how systems work by simply experimenting and trying stuff out. Don't be afraid to experiment. That would be my advice.
All right. Jay, any other feedback?
Now, I'm very active in the background. This was a really good crowd. I hope that's a good sign that people enjoyed it and found it useful. We always take into consideration that your time is very important. So really glad that you came, glad that you interacted with us, and we'll see you again soon.
Yeah, we're going to be at a bunch of conferences coming up over the next month. Jay and I will not see our family for probably another month or so. So many of you will be near you. So if you have a chance, we look forward to meeting you face-to-face at our booth. So come by, and we'd love to get your feedback and hear about some of your challenges and things you'd like for us to share on webinars. So everybody have a great day and a great weekend. We will maybe see you in Scottsdale, or check in on retrotech.com's website to go over and find our webinars and where we're located.